In this video, we're going to start talking about how to graph a more complicated tangent function. So here we have example 1, graph y equals 3 times the tangent of 2x minus pi over 2, and then minus 1. Okay, so a couple things with this video. There's a set of steps we're going to follow, and some graph paper that we're going to use in the end. So if you want either one of these and you don't have them yet, there's a couple links in the video description, and you can click on those links, open these up, and print them out and follow along if you'd like. Okay. So we'll set the graph paper aside for now. We'll use it more towards the end. So here on this sets of steps here, this first box is for tangents and cotangents. This is for secants and cosecants, so we're not going to focus on this box yet. This will be for a separate video. Okay, so here we're going to just look at the top box up here. Okay, so let's just go ahead and jump right in there. Okay, so graphing tangents and cotangents. Step 1, find the period, which is t. Period is usually denoted capital T. And it's equal to pi divided by the absolute value of omega. Just like with sines and cosines, so except sines and cosines have 2 pi, so that's the only difference here is instead of 2 pi we have the pi. And we did talk about this, why it's pi over absolute value of omega. We talked about that in an earlier video fairly recently. So anyway, find the period t equals pi over the absolute value of omega, and find the general equation of the vertical asymptotes. And we talked about how to do this with the asymptotes in a separate video. So we're going to go through the same process here, but we won't really focus too much on the details because we don't want to take up too much time in this video. Okay, so anyway, first with the period, we have to know what is omega. Okay, we have to find omega first. Well, here, just like with sines and cosines, the general form of the equation is y equals a times the tangent of omega x minus phi plus b. So omega is the thing being multiplied by the x. Okay, so if we zoom back out here a little bit, we look and say, okay, what's being multiplied by the x? Well, it's this 2 right here. Okay? So omega is 2. Okay? So then right away we can just say, okay, the period is t equals pi over the absolute value of omega. And since omega is already positive, the absolute values, we don't need those, we can drop them. So this is just going to be pi over 2. Okay? So that's finding the period. Now we have to find the general equation of the vertical asymptotes. So what we're going to do is follow that same process we did in the other videos, where we found the vertical asymptotes and didn't really do anything else. So first we say original, as in the original equation of the original general equation of the vertical asymptotes for the tangent, just plain old y equals tangent of x. Okay, so that's for y equals tangent of x, the general equation is x equals k pi plus pi over 2, where k is any integer. And I'll abbreviate that int for short. Okay. So remember, x equals k pi plus pi over 2, where k represents any integer, because so k could be 0, 1, -1, 2, -2, 3, -3, 113, -4,000, and so on and so forth. Okay, okay, so continuing with that, now, just like in those other videos, what we do is say new. Okay, so this is this right here is for y equals the tangent of x, but we don't have the tangent of x. We have the 3 times the tangent of this big mess here, and then minus 1. So what we do is take everything inside of the tangent. Okay, take everything inside of the tangent, which is 2x minus pi over 2, and then set that equal to k pi plus pi over 2. Okay. So we went through this process in an earlier video and explained why it is the way it is, so we won't focus too much on that here. We'll just go continue with the process. Okay, so what we have to do here is solve for x. Okay, so we want the general equation of vertical asymptotes, so it has to be x equals something, because they're vertical lines, vertical asymptotes. It has to be x equals something. And we're still going to have a k in our answer, which we should, because it's a general equation. Okay, it's not one specific asymptote, it's a general equation covering all of them. So anyway, solve for x. So first we add pi over 2 to both sides. So now 2x equals k pi plus, so we have plus pi over 2 and then plus another pi over 2 from adding pi over 2 to both sides. So pi over 2 plus pi over 2, that's 2 pi over 2. Okay, 2's cancel, we're just left with pi, so this is k pi plus pi. Okay, so that's fairly simple there, that's good. Now we're solving for x, so we divide everything by 2. Okay, so then x equals k pi plus pi all over 2. Okay? And if we want, we could split it up into 2 fractions, but there's really no need. We'll just leave it like this, and it's comma k as any integer. Okay, so we'll just put that there just to be thorough. Okay, so that's it for step 1. Okay, find the period t equals pi over absolute value of omega, and find the general equation of the vertical asymptotes. So this here is the general equation of the vertical asymptotes. Okay, so now in step 2, we want to find 2 consecutive asymptotes by plugging k equals 0 and k equals 1 into the general equation. Okay, so here in step 2, we say to use k equals 0 and k equals 1. Now we don't have to use those values specifically. We can actually use any 2 consecutive integers we want. Okay, but the point is we have to find 2 consecutive vertical asymptotes, because we want to, basically the goal here is to graph one period of this function. So to graph one period of this function, we're going to have to get 2 asymptotes that are next to each other. Okay, so the way we do that is by plugging in 2 consecutive values of k. Okay, so values of k that are next to each other are going to give us vertical asymptotes that are next to each other. And it's good to use 0 and 1 for k, because pretty much the goal is to stay close to the origin. So if we use large values of k, like 101 and 102, we'll be pretty far out to the right. Okay. Now it's generally the case that k equals 0 and k equals 1 will keep you near the origin, but if, so here this is our phi, right? So remember, it's omega x minus phi. So if we have crazy numbers for phi and omega that are in such a way that, it's basically if phi divided by omega is some really huge number, then you might have to use different values of k to stay near the origin. Okay, but it's not really likely that you'll deal with something like that. But even if you do have to deal with something like that, it doesn't actually matter. It's just nice to stay near the origin. Do we really have to? No, not unless we're told to. But it doesn't matter. The point is to graph one period of this function and then extend it as necessary using the period and vertical asymptotes and things like that. But we'll talk about that when we get there. So anyway, for step 2, find 2 consecutive asymptotes, and we're just going to do k equals 0 and k equals 1 just to keep it simple. Okay. So we're going to set up that chart like we did in those other videos. So our chart's going to be k and then VA for vertical asymptote. So when k is 0 and k is 1, we're going to see what we have here. Okay, so when k is 0, we have x equals 0 pi plus pi all over 2. 0 times pi is 0, 0 plus pi is pi, so that's just pi over 2. And again, we mentioned it in all those videos, but VA, it's an equation of a vertical asymptote, vertical line, so it has to be x equals pi over 2. So just be careful about that. It's not quite right to just say pi over 2, because you're talking about a vertical line, so we have to express this as an equation of a vertical line. Okay, so that's if k is 0. What if k is 1? If k is 1, then x equals 1 times pi plus pi all over 2. 1 times pi is pi, pi plus pi is 2 pi, so this is 2 pi all over 2, 2's cancel, we're just left with pi. So x equals pi. Okay, so those are our 2 consecutive vertical asymptotes. Nothing too complicated. So that's it for step 2. Now step 3, divide the interval between these asymptotes into 4 equal parts. This will give you 5 x values. Okay. So this is similar to something we did with the sines and cosines. Okay. So what we're going to do is we're going to take the interval between these 2 asymptotes and divide them into 4 equal parts. So what we do then is, let's maybe use a different color. Okay, so we'll put pi over 2 here, and we'll put pi over here. Okay, so here's our asymptotes, x equals pi over 2 and x equals pi, so we'll put pi over 2 here and pi here. Pi is larger, so it goes further to the right. So now we want to divide this into 4 equal parts. So how do we do that? We just divide it in half. Okay, divide this little interval in half, and then we have to figure out what goes here. Well, this is pi over 2, this is pi. We want to know what's exactly halfway in between them. Well, we just add these 2 guys up and divide by 2. Okay? So pi over 2 plus pi. Divide that by 2, it's the same thing as multiplying by a half. So we just have to figure out what this is. So inside of the parentheses, let's get a common denominator. So if you multiply the pi by 2 over 2, then we'll have a common denominator. So this is pi over 2 plus 2 pi over 2. That's 3 pi over 2. And then we're still multiplying by a 1/2 here. Okay, so we still have that 1/2 there. So 3 pi over 2 times 1/2, that's 3 pi times 1, or let's just say 3 pi over 4. Okay, so 3 pi over 2 times 1/2 is 3 pi over 4. So that's what this guy is right here, 3 pi over 4. Okay. Now remember, we're dividing this whole thing here, this whole thing we're dividing into 4 equal parts. So now we have to do basically that process again. So let's divide this one in half. Then we have to figure out what goes here. So what we do is add up these 2 guys and divide by 2, because this is halfway in between. So that if we add up these guys and divide by 2, that's going to give us that. Okay, so let's go ahead and do that. So pi over 2 plus 3 pi over 4. And dividing by 2 is like multiplying by a half, so we're going to multiply this whole thing by a half. And I left some room over here because what we have to do is get a common denominator. So denominator 2, denominator 4. The lowest common denominator is 4, so we multiply this guy by 2 over 2. Okay. So this is 2 pi over 4 plus 3 pi over 4. So 2 pi over 4 plus 3 pi over 4, that's 5 pi over 4. And we're still multiplying by this 1/2 out here. So this whole thing altogether is 5 pi divided by 8. Okay. 5 pi divided by 8. Okay, then we do it one more time with this one right here. And again, same exact process. Add these two guys up and divide by 2 to figure out what this guy is right here. Okay, so let's get rid of this. Now 3 pi over 4 plus pi, and we're going to divide that by 2, so 3 pi over 4 plus pi, all divided by 2, but dividing by 2 is like multiplying by a half. So now what we do, we have to get a common denominator in here, so multiply pi by 4 over 4, okay? And then 3 pi over 4 plus 4 pi over 4, that's 7 pi over 4. And then that whole thing is still being multiplied by a half. So this whole thing altogether is 7 pi over 8. Okay, so 7 pi over 8 is what goes right here. Okay. So that's pretty much it for step 3. Okay, so that was divide the interval between these asymptotes into 4 equal parts. That's what we just did, and then this will give you 5 x values. So now we have 5 x values. We started with 2. Okay, we already had pi over 2 and pi at the beginning, but now we have 5 total x values. Okay, but the pi over 2 and the pi don't really matter now. So for step 4, all that really matters are these 3 in the middle. Okay, so for step 4, find the y values at the middle 3 x values, because remember the asymptotes are at the other 2 x values. Okay, so again, it's still pretty similar to what we were doing with sines and cosines, but with sines and cosines we found the y values at all 5 points, but we can't do that here because we have vertical asymptotes at pi over 2, at x equals pi over 2 and x equals pi. Okay, but we can evaluate the function at these 3 points here, which is exactly what we're going to do. Okay, so let's come up here, we'll make a little room. Let's set aside some space. Okay, so we're going to evaluate this messy function here at all 3 of these points one at a time. So let's start with 5 pi over 8. So when x is 5 pi over 8, what's going on here? So what we have is y equals 3 times the tangent of 2 times x, and x is 5 pi over 8, so 2 times 5 pi over 8. And then we still have this minus pi over 2 in there. So minus pi over 2, and then minus 1. Okay. So now we just have to simplify and evaluate. So this might look like it's not going to work out nicely, but what's actually nice about this process is even if you have crazy goofy numbers here, the way everything works together is that once you simplify this, you'll actually get a nice expression in here that you'll easily be able to evaluate as long as you know the unit circle fairly well. Okay. So continuing with this, so that's going to give us 3 times the tangent of, okay, so 2 times 5 pi over 8, all minus pi over 2. So let's simplify that outside here. So 2 times 5 pi over 8 minus pi over 2. We'll come off to the side separately and simplify. So 2 goes into 8 4 times. So this is 5 pi over 4 minus pi over 2. Get a common denominator of 4. So multiply this by 2 over 2. Okay. So that's going to be 5 pi over 4 minus 2 pi over 4, which is 3 pi over 4. Okay. So what goes in here is just 3 pi over 4. Okay, and that's nice. That's not too complicated. Then we still have a minus 1 here. Okay. So now here's where our knowledge of the unit circle comes in handy. So what is tangent of 3 pi over 4? So if you remember the unit circle, think back and remember that tangent of 3 pi over 4, that's negative 1. Okay, so this is 3 times negative 1 minus 1. 3 times negative 1 is negative 3. Negative 3 minus 1 is negative 4. Okay, so this gives us the point 5 pi over 8 comma negative 4. Okay, because what we just found out is that when x is 5 pi over 8, the corresponding y coordinate is negative 4. Okay. Okay, so that's for the first x value in the middle here. Now we use this second x value in the middle, so 3 pi over 4. So when x equals 3 pi over 4, what's going on? What's going on is y equals 3 times the tangent of, okay, so we're still using this function here as tangent of 2 times 3 pi over 4 minus pi over 2. Still have that minus 1 out there. Okay. Now, this one's actually a little bit easier to simplify, so let's zoom in a little also. Okay, so then this equals 3 times the tangent of what? Well, 2 goes into 4 2 times, so what we have is 3 pi over 2 minus 1 pi over 2, which is 2 pi over 2. Okay, so 3 pi over 2 minus pi over 2, that's 2 pi over 2. 2 pi over 2 simplifies to just pi, so it's just tangent of pi in here. Okay, that's good. Then we have a minus 1. So tangent of pi, if we think about the unit circle, remember, it might help to remember that tangent is sine divided by cosine. So tangent of pi is actually just 0. So this is 3 times 0 minus 1, which is negative 1. Okay? Alright, so we have that. So that tells us that when x is 3 pi over 4, the corresponding y-coordinate is negative 1. So this gives us the point 3 pi over 4, comma, negative 1. Alright. Now, lastly, we do the same thing for this third x value in the middle here, so 7 pi over 8. So when x is 7 pi over 8, what's going on? So we have y equals 3 times the tangent. So again, we're just plugging in these x values. We're plugging them into the original function up here. Okay, so y equals 3 times the tangent of 2 times 7 pi over 8. And then minus pi over 2. And then minus 1. Okay, and then let's simplify that separately down here real quick. So 2 times 7 pi over 8 minus pi over 2. Okay, so 2 goes into 8 4 times. So this is 7 pi over 4 minus pi over 2. Common denominator is, least common denominator is 4, so multiply this guy by 2 over 2. So that's 7 pi over 4 minus 2 pi over 4, which is 5 pi over 4. Okay? So then this whole thing inside the tangent here is 5 pi over 4 is what we just found out right here. Okay, so let's erase this, make some room for ourselves. So then this whole thing is 3 times the tangent of 5 pi over 4. And then minus 1 is still there. Okay, so then this equals, so think about the unit circle again. So tangent of 5 pi over 4, what is that? Well, it's positive 1. So this is 3 times positive 1 minus 1. 3 times 1 is 3. 3 minus 1 is 2. Okay? Okay, so this tells us that when x is 7 pi over 8, corresponding y-coordinate is 2. Okay, 7 pi over 8, comma 2. Okay, so we have that going on there. That's nice. Alright, so now let's go back to our steps here. So step 4, find the y values at the middle 3 x values, because the asymptotes are at the other 2 x values, so that's it for step 4. Okay. Now I want to point out a little shortcut here. When we found the first 2 points, so the y-coordinate here was negative 4, and the y-coordinate here was negative 1. So what you can do is say, okay, if I take negative 4 and I add positive 3 to it, then I get to negative 1. If I take negative 1 and I add positive 3 to it, I'm going to get positive 2. Okay? Negative 4 plus 3 is negative 1. Negative 1 plus 3 is positive 2. Okay? So you can kind of use that as a shortcut to check yourself to see what point this is. Okay? Now, I don't recommend doing it that way and not showing the work, because if you're doing this on a quiz or a test or a homework assignment, you might have to show work in some way. And it might not be okay to just say, well, hey, negative 4 plus 3 is negative 1. So if I take negative 1 and add 3 to it, that gives me the other y-coordinate. Okay, that'll work like that. But if you have to show work and show what you're doing, you know, be careful with that. But it's a good thing to use to check yourself. Okay, but anyway, so moving on. So step 5, if a scale is not set up on the graph, let the x-axis scale be t divided by 4. So remember, t is the period that we found way back in step 1. Okay, yt divided by 4, we'll talk about that when we graph it. And let the y-axis scale be something convenient and relatively similar. Okay, so let's do that right now. Okay, so let's pull out the graph paper, because we're kind of out of room here. Actually, I guess we can come back up here real quick. Say, okay, if t is pi over 2, so let's figure out what t divided by 4 is. Okay? So t divided by 4, that's the same thing as multiplying by 1/4, right? So this is pi over 2 times 1/4. Okay, remember, dividing by 4 is like multiplying by 1/4, and we know that t is pi over 2. So t divided by 4, let's just write this. So that's the same thing as t times 1/4, okay? And t we already know is pi over 2. So pi over 2 times 1/4, that's pi over 8. Okay, okay, so pi over 8 is going to be our x-axis scale. Now, do we absolutely have to use that scale? No, we don't really have to, but it is going to make things a little easier for us if we use that scale. And we'll talk about why, and we'll see how when we start graphing it. So what do we mean by x-axis scale? So what we were saying was let the x-axis scale be t divided by 4. So what that means is if we have our little graph paper here with the grids on them, let each grid mark in the x direction be pi over 8 units, in this case pi over 8. So in general, take t divided by 4, and each grid mark will be whatever that value is. Okay. So, and again, we don't have to do it like that, but it's just going to be a little easier that way. Okay, so let's zoom in here a little. And we'll set up our y-axis. And our x-axis. Okay, so there's our x-axis, here's our y-axis up here. All right, now, so we're going to set up our scale. So remember, let the x-axis scale be t divided by 4, and let the y-axis scale be something convenient and relatively similar. So what does that mean, convenient? So, you know, don't let the y-axis scale be something crazy and goofy. Let it be convenient as far as your y-coordinates go. So our y-coordinates are -4, -1, and +2. So we shouldn't use something like pi over 8 for the y-axis scale. That'd be weird. Okay. Now, anyway, okay, so getting back to this. So our x-axis scale is going to be pi over 8. So this here is pi over 8. Okay, this next one is 2 pi over 8, which simplifies to pi over 4. This next one is 3 pi over 8. This next one is 4 pi over 8, which simplifies to pi over 2. This next one is 5 pi over 8. This one is 6 pi over 8, which simplifies to, if we pull out a common factor of 2, that's going to be 3 pi over 4. And this one here is 7 pi over 8. Okay, so it's getting kind of cramped in there, but anyway, this one here is pi. I think that's a good place to stop that. So now let's also go back in the negative direction. So negative pi over 8, negative pi over 4, negative 3 pi over 8, okay, and then negative pi over 2, and then negative 5 pi over 8, so negative 3 pi over 4, negative 7 pi over 8, and negative pi. So this doesn't get too cramped. Let's maybe just label. So this is negative 3 pi over 4, and this is negative pi. You know what, we better label all of them. Yeah, all right. So indecisive here. All right, anyway, this one was negative 5 pi over 8. Okay, so cramped, kind of a big mess. So that's why, you know, if you want, you could spread it out a little bit, or maybe if you have graph paper with larger grid, but anyway. So that's our x-axis scale. Now, the y-axis scale, let it be something convenient and relatively similar. So we already explained convenient, so that means don't use the same scale for y. You can if you want to, but it's just going to be hard to plot y-coordinates of -4, -1, and +2. Okay, so why relatively similar though? Because we want to keep it relatively similar so that the graph doesn't look distorted, like it doesn't look too stretched out or anything. Okay, so pi over 8, pi is about 3.14. So 3.14 divided by 8 is a little under a half. Okay, so it's a little bit under a half. So we'll let each mark in the y direction be 1/2. So that's 1/2. That's 1. Okay, so it's convenient because it's easy to find coordinates of -4 and -1 and +2. It's easy to find those, and it's also relatively similar. Okay, we could do a little better maybe, but it's similar enough for what we're trying to do. Okay. 3, 4, 5. -1, -2, -3, -4, and -5. Okay, so again, each mark in the y direction is a half of a unit because we want to keep y convenient and relatively similar. And since pi over 8 is a little under 1/2, because pi is 3.14-ish, pi is approximately 3.14, 3.14 divided by 8 is a little under a half. So each grid unit in the x direction is a little smaller than 1/2. So we want to keep y convenient and relatively similar. So we'll let each y grid unit be 1/2. Okay. All right, now we just start, let's go back to our steps. So graph the asymptotes. So we'll graph the asymptotes first, and then also plot the 3 points that we found in step 4 and smoothly connect them using, or with the general shape of tangents and cotangents. Okay. So this is a pretty straightforward step. Once we have the scale set up, and again, you might actually be given a scale to work with already, which would save you a lot of trouble, which is really nice. But if you're not, then that's how we do it. Just take the period, divide it by 4. Okay? And we still haven't explained why yet, but we'll see once we start plotting points. Okay, so the first point we're going to plot is 5 pi over, so let's zoom out a little bit. Okay, so what do we have? We have 5 pi over 8 comma -4, 3 pi over 4 comma -1, 7 pi over 8 comma +2. But first, actually, let's graph those asymptotes. So remember they were, this one got erased, but this was x equals pi over 2. Okay, x equals pi over 2, and this was x equals pi. Okay, so let's go ahead and graph those asymptotes. And then we're going to graph those 3 points we talked about. Okay. Okay, so x equals pi over 2, that's this asymptote right here. Okay, so we'll extend it all the way down there, and then make sure we label it just to be thorough and safe. X equals pi over 2, and then do the same thing here with x equals pi. That's the other vertical asymptote we found. Okay, x equals pi right here. Okay, so now we're going to plot those 3 points. So they were 5 pi over 8 comma -4, 3 pi over 4 comma -1, 7 pi over 8 comma 2. Okay, so notice, because of how we set up our scale, well, look at this, 5 pi over 8, 3 pi over 4, 7 pi over 8. Those are all 3 of our x-coordinates, right? So 5 pi over 8, 3 pi over 4, 7 pi over 8. Notice that's the 3 x-coordinates we had, 5 pi over 8, 3 pi over 4, 7 pi over 8. Okay, so when we divided that interval into 4 equal parts, back in one of the earlier steps, back in step 3, okay, that gave us these 3 x values. So that's why we use, for the scale, we use the period divided by 4, because we divided that interval into 4 equal parts. So if we divide the period by 4 and use that as our scale, then these numbers will always show up here. So it makes it really convenient for us. That's why we do that. But you don't have to use that scale. You can use any scale you want, really. Just make sure it's simple enough to work with and that it makes sense at least. But anyway, so 5 pi over 8 comma -4, that's this point way down here. 5 pi over 8 comma -4, and then 3 pi over 4 comma -1, and then 7 pi over 8 comma 2 was our other one, so 7 pi over 8 comma 2. Okay. All right, now the rest of step 5 was plot the 3 points and smoothly connect them with the general shape of tangents to cotangents. Okay, so be very, very, very careful because, yeah, these 3 points that we just drew, they are collinear, okay? They all fall on the same line, but don't connect them with the straight line. Connect them with the general shape of tangents and cotangents, which I'm about to totally screw up here. But here goes nothing. Oh, that could be worse. And that even looks like a straight line, but the problem with this is it's really stretched out because of this 3 here. So this 3 stretches it out vertically quite a bit. So this one's a tough one to really draw well, which is something I struggle with anyway. Okay, so we'll extend that downwards also. Okay, so, oh, that is just atrocious. All right. Anyway, the point here is just connect it with the smooth, smooth curve here in this general shape of tangents to cotangents, which would be easier if it wasn't also stretched out. So actually, maybe if we let the y scale be 1 instead of 1/2, it'd be easier to see, but still, it'd actually be a little distorted because this 3 here really does stretch it out quite a bit. So it should look a little stretched out as long as our scale's set up nice enough. Okay, so anyway, that's it for step 5. Now step 6 says use the period and general equation of the asymptotes to graph more cycles if necessary. Okay, so you might be asked specifically to graph maybe 2 or 3 cycles. So let's graph 2 more cycles to the left, and then that'll be it for this problem. Okay, so we can use the period and the general equation of the asymptotes. So remember way back in an earlier step, we used k equals 0 and 1. So k equals 0 gave us this asymptote here, x equals pi over 2. K equals 1 gave us the next one to the right. So k equals 0, k equals 1. Well, k equals negative 1 will give us the next one to the left. K equals negative 2 gives us the next one to the left after that. K equals negative 3, k equals negative 4, and so on and so forth. K equals positive 1 gave us this one, right? So k equals positive 2 will give us the next one to the right. Okay. So that's how we can use the general equation of the asymptotes to plot more. But we can also just use the period, because what is the period? Remember we found way back in step 1, the period is pi over 2. So every pi over 2 units, everything starts repeating. So we can actually use that to our advantage. So here we have a vertical asymptote at x equals pi over 2. So let's go pi over 2 units to the left. Well, that's going to be right at x equals 0, right on the y-axis. So we'll have another vertical asymptote there. Okay? So remember, every pi over 2 units, the graph starts repeating. That includes the asymptotes. Okay, so since we have an asymptote at x equals pi over 2, there's another one pi over 2 units to the left, and another one pi over 2 units to the left of that. So let's graph that one also. So this would be x equals negative pi over 2. Okay, x equals negative pi over 2. Okay, now we can use the period to plot more points here. So actually, so you could look at this and say, okay, 5 pi over 8 minus pi over 2, where's that going to put me? You could do that, but you can also say, well, hey, I only have these 3 x values in the middle, and I know that at the first one, the y-coordinate was negative 4. Okay, so the same thing is going to happen in each of these intervals. Okay, I have 3 x values in between 0 and pi over 2. Okay, this first one here is pi over 8, so same y-coordinate is going to be negative 4. At the second x value, the y-coordinate was negative 1. Okay. Now, if you have to show work, of course, you could just show that 5 pi over 8 minus pi over 2 is pi over 8. You get a common denominator, things like that. So anyway, continuing. So this point up here was the other one, 7 pi over 8 comma positive 2. So this here, 3 pi over 8 comma positive 2. Okay, so the third x value in the interval has y-coordinate positive 2. And we'll connect those with the general shape of tangents to cotangents. Here we go. Oh, that's just appalling. Ugh. Alright, well at least it looks similar to this one. I'm not sure how much of a good thing that is. So anyway, now let's do it one more here. So, okay, we already have this asymptote graph. So now 3 x values in between these two vertical asymptotes. At the first x value from the left, the y-coordinate is negative 4. Okay. At the second x value from the left, or the one right in the middle, the y-coordinate is negative 1. So this is negative 3 pi over 8 comma negative 4, negative pi over 4 comma negative 1, and then negative pi over 8 comma positive 2. Okay, so we'll connect those with the same general shape of tangents to cotangents. Oh, what a mess. Alright, well that's just awful. So anyway, if this wasn't stretched out so much, it'd probably look a little bit better. But anyway, it is what it is. So that's really it. Okay, that's our last step. That's step 6. Use the period and general equation of the asymptotes to graph more cycles if necessary. So you don't really have to use both of these. You could use either one for tangents to cotangents. Okay, so this is our function y equals 3 times the tangent of 2x minus pi over 2. And then minus 1 also. Okay, so that's it for graphing a tangent function. More stuff coming up in later videos.